Hi, my name is Wayne Francis. I'm the engineering lead for the AutoDive muscle platform that you see behind me here. What I'd like to do is walk you through some of the design features and some of the activity that we've put forward in building this system. What you see behind you here is the platform itself. This platform is intended to be a 20 by 20 support structure for the ropes that the mussels adhere to as they grow. This platform will support up to 40-foot long ropes, and we expect that they would be on a grid along the 20 by 20 wood structure. The top platform is a wooden structure built with 6 by 6s, and there are 10 of those strung across the length, and they form the structure along this axis, with the displacement vessels themselves forming the structure along this axis. What you'll see here is we have a displacement tank which will contain a water-air mix. The compressed air pushes water out through the exit pipes, which are located here at the end, and then intakes will be suspended into the water on this side. Those intakes will bring water in, as well as air coming from the compressed tanks, which I'll show you in a few seconds on the side. The top vessels, of which there are two, are dry wells. They contain our batteries, our electronics, our communications gear for the platform itself. Those electronics are specifically designed to be able to maintain the system along with the compressed air stored in the side tanks for a period of 3 months, servicing the weight growth of the mussels themselves, as well as the weight growth associated with fouling. The buoyancy of this system is compensated for by weight in the mooring, as well as the weight of the platform itself, and the controller brings the buoyancy of the system up until it hits a single weight stop that's associated with the mooring, and then it has a little bit of margin in it because of that weight before that weight's pulled up off the seabed. Once you overcome that weight margin in the buoyancy, then it will rise to the next stop up or even to the surface. As it sits here, this platform full of air is positively buoyant, will come to the surface. It actually can't, once you fully evacuate these tanks of water, it actually cannot submerge until you once again prime it with water. So in the operational state, it'll come up to right about here, and getting the platforms themselves clear so that you can service the platforms by walking on them. Again, these are standard bell ends for pipe fittings, and so all of our electronics are bolted to an end cap in the dry well set in there. I'll show you some of the electronics that we used to evaluate sensors and control valves when we move to the interior. Next, I'm going to show you the major components. Again, we have the support superstructure at the top. We have the displacement tanks, and then along this edge and then this edge behind me, we have the compressed air tanks, which are made out of highly thick stainless steel pipe. All of the stainless steel superstructure is coated with primer and paint that will reduce the erosion due to the salt water touching the metals that happens within the ocean. This is designed with a service life measured in years in that harsh salt environment. So next, let's take a look at the structure from the end to give you an idea of its dimensions from an angle, and then we'll move on to our local wet laboratory testing site.